Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 380. Find beautiful indexes and giving away two. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, it is a harder version of Q2, but to be honest, it is not a hard problem. It is a hard problem, and if you don't know how to solve it, it probably is just that you don't know how to solve this. And that may sound, I don't know, I hope it doesn't sound too insulting or patronizing, but what I mean by that is just that there's a couple of specific algorithms, and if you knew them, then this is straightforward. If you didn't know them, this is going to be probably impossible just because, it's a knowledge thing. And then the other thing is that, and I actually wrote this live, so if you watch the live portion, I typed it out. But my suspicion is that a lot of people have template for this problem, and as a result, I wouldn't compare my time to them. I mean, I have to, but you know what I mean. There's a lot of templates because it is a very standard. I don't know about if it's a very standard, but it is a standard enough problem in competitive programming that people have libraries for this, because I've seen it, but I don't. But obviously, but I've seen it, right? I probably should actually, but that's besides the point. And the biggest thing here is going to be warp and cop. Or another way to think about it is called rolling hash. And rolling hash is probably a bigger way of thinking. Or I don't know. For me, it's just more self-descriptive. And these are things that you can Google. We'll go over it in this video briefly, but probably not in super high detail. But yeah, but that's basically the idea. And the idea here is okay. How do I even go over this? I mean, we'll go over this. But basically, let's say we're able to have this as a black box, and like I said, a lot of people do. I'm able to get all the indexes where it matches, all the indexes that it matches B, and then we just do this binary search thing. I'm going to upsolve this using the 2 pointers thing that I talked about, but I'm not going to do it quite yet. So hold on for a second. But yeah, and this part I already explained in Q2, but it's just binary search, right? So given that we have indexes, you can also use 2 pointers to kind of point them forward. I would recommend using the 2 pointers, especially during an interview, because that's linear time. Here, this is going to be n log n times, but for me during the contest, well, for me, especially for Q4, I've already done it in Q2, so I'm not going to rewrite it, right? I mean, hope that makes sense. But at least during the contest, I mean. But yeah, and this is the rolling hash. Like I said, this is way templatable. I'm really sure that a lot of people do have it. Here, I just choose a random number for a base, or random number bigger than 26, and in mod, I just kind of Google for random prime. And honestly, during the contest, I had to refresh myself a little bit. Like, I have to be like, oh man, I knew how to do it, but I just kind of, I don't know, a little bit rusty on it. But yeah, but the idea behind rolling hash is that, okay, right, so I'm just going to give a very brief overview. If you want to know more, definitely, like I said, Google up warp and cop or rolling hash. It should be very straightforward. I probably have explained this in the past, but today I am a little bit tired. And also, like, yeah, I don't know. We'll see. But yeah, but the basic idea is still just going to be, in a way, brute force, in that, okay, you look at the string, you have this other string, and you're just literally trying, okay, does this match IS? No. Does this match? Does this match? And you just keep on going, right? And of course, the way that you do this, if you do it very naively, it's going to be O of n times m, because you have two characters or m characters and the other string, and you're doing naive comparisons. The idea behind a rolling hash, and you can also, there are other algos for this as well, but the rolling hash is the one that I like, is that you take advantage of very cheap operations, but makes it probabilistic as a result. But basically, let's say you have, and maybe this is a little bit longer, because in this case, m can be 10 or 5 times 10 to the 5th, and mine is, it hashes to some number. I'm just going to bang on the keyboard. It's not what, I don't know what the hash is. Whereas 124. So then the idea here is that we calculate the hash of these two numbers, or these two characters, and you get some number, I don't know, right? Whatever, 52. And then now you have SA, but then the idea is that you can shift this number to times the base, so you can shift this by a little bit, and it'll and because of the mod, this actually only bounds it by the number of digits, right? So it's a very cheap operation relatively, or like I don't know what this number log base is, but let's say it's 20, not even, probably like 10, right? That means that you're only effectively comparing 10 digits, but basically you're training some probability and false positives for really fast algo, right? But you times it by base. Basically, it's a shift and add thing, and you kind of see it here, right? You shift, you add, you mod, and then you keep on doing it on the hash key. But then on here, you also want to, in a way, it is sliding window, right? The core idea behind the rolling hash, for me anyway, to understanding it, is sliding window. And basically, for example, this is too short, but let's bang out a few more, right? So then now here, what shift and add is that, okay, you shift to add the u, and then after you add the u, you also subtract the s, right? So that's basically the idea, right? Is that you add the u, you shift everything by 1, and then you subtract the s in some order. And that's basically what the idea behind Robin Cobb. That's all I needed. I mean, I know that maybe I'm going a little bit fast, and maybe I'm not putting enough details, but to be honest, that's the detail I needed to refresh myself during the contest to implement everything. I implement everything from scratch. You can look at it up. And I'm not judging people who have templates or whatever. I wish I had the template, because then now I would have gone like 5 minutes faster or something like that. But but basically here, I shift, I add, I subtract out the like a sliding window kind of way, and then I make sure that I mod. In Python, you could get mod on the negative number, which is why this looks okay. But and then now if this is long enough, just a little bit of a minor thing, but also if the current is equal to AK, that means that the hashes match. Then now we append the first, just getting the first, the beginning of the string, and that's pretty much it. Everything else is the same as Q2. So what's the complexity here? With the rolling hash, this is going to be linear, right? So this is linear. It returns linear number of indexes. This is basically also linear on M, and this is linear on N. Technically, I guess this is O of N times some, depending on the base and the mod. And of course, that there's some discussion there about like the trade-offs with respect to time and space versus false positives and probability and stuff like that. In a contest where if it's like code force or something like that, someone will challenge this and you will get it wrong. It is what it is. But I think on Leetcode they don't let you, or I hope not, because otherwise I'll be a little bit sad. But otherwise you have this thing, and that's n log n, so this is going to be n log n. As an upsolve, I am going to be for the upsolve, I am going to try to do this with whatchamacallit, with 2 pointers. So let's give it a try. I like 2 pointers with dex just because it's slightly easier. But so while length of AR is greater than 0, right? So then here, maybe I write something like, so these are all indexes, and then now we want to say while length of BR is greater than 0, maybe I'll do this as a set just because I'm a little bit lazy on the checking. I think I could, I don't need to do this, but I'm just lazy. But then now, if the first index is less than, then we want to pop left. But even before we pop left, we can do a check. So if absolute value, I mean, I know that this goes one way, but I'm just lazy on whatever. Okay, then we can answer.add a of 0 because this index is good. And then here, now BR of 0 should be greater than AR of 0 if and only if it has a length. So maybe something like if length of BR is greater than 0, and then now we could just copy and paste this, I think. right? And then here we want to pop left. I think this is good for linear. It's still actually kind of ugly, but do I have a infinite case somewhere because I forget to? No, this pops. Why is this time limit exceeded? Oh, this doesn't always pop. If this is bigger, then we else break. Whoops. Yeah, whoops. But this is why you know, a lot of silly possible mistakes with the 2 pointers. This is why I did it with binary search. But why? Tell me why. Huh. Lucky I didn't do that during the contest, right? But yeah, so 2, 3, 4. We have. Oh, that is a good edge case. I thought about doing it this way before, but wow, that is actually rough. I take it back. I don't know if I'm wrong on this one. I don't know that this is binary search. I thought it could be, but I was very wrong. So okay, I mean, sorry, I don't know that this is 2 pointers. I was very wrong on this, huh? All right, well, it's a good thing that we did binary search during contest. Yeah. And if you watch Q2, I apologize for making that mistake. Huh. Yeah, all right, well, let's submit again just to make sure. Why is this taking so long? That would be... Did I do something else? Man. Well, it's a good thing that during when I first submitted it's fast enough. No, I mean, maybe I just did something. Did I change something by accident? Oh. Whoops. I did, because I changed it to dex. And then it tries to do a binary search on a deck, which is not very efficient because there's no random memory access on dex. I'm very silly boy. But yeah. All right. Whew, that's all I have for this one. Let me show you the code. This is my Robin Corp. I always choose a random mod. I don't know. It doesn't really matter. Random prime. But yeah, but this is the top. This is the Robin Corp. This is the binary search. And apparently you need the binary search. So I'm glad I did it that way. But yeah, let me know what you think. And you could watch me solve it live during the contest now. Okay, maybe. Let's give it a submit. Oh, good. Wow, a lot of people got Q4. Oh, this is the second problem or something, right? What is the catch? Oh, I mean, this is just whatchamacallit? Yeah. I mean, I even mentioned in the other one. Okay, what am I doing? I haven't done it in a while though, but let's do it. Oh no. Oh. It's kind of sad because I think a lot of people have template for this. I'm just trying to find a big prime. 20-digit prime. Okay. Right. It's just a random prime. And then now. Let me also get that back up so I could kind of have the structure. Okay. All right, well. I guess this is right, so we'll just keep this. Right. I actually forgot about this. I mean, I forgot that there's a part 2 possibly. But oh well. This is the mod. Whatever. It doesn't really matter. Okay. I forget how to name things. But okay, and then now I guess I needed that instead, but yeah, whatever. You don't have to clean up your code. Okay, fine. Right, what is the oh, it could be very long. Actually, I have to be careful. Is that right? This one, yeah, it should be right. Oh, I don't need to do this a little bit better. Or maybe just memorize the number at this point. Of times. That's not great. Am I off by one somewhere? Well, that's not good. What am I doing wrong? Why is this 2 so big? Oh, because of the subtraction? Oh, dummy. How did I get the other one? But okay, still wrong, but that's clearly wrong. This is really weird. It shouldn't grow that much. Okay. Oh, +1. That's the way I do it. This is still off by some stuff. That's why it's growing. Okay. 1734. Am I right? Nope. Because I have an off by 1. Why do I have an off by 1? Actually. I'm just returning the. I am returning the wrong thing, but why am I off by 1? Oh, this is the index of the n. So then we want to index -m. +1. Also, am I printing stuff? I am printing stuff. Not that much though, but 1633. All right, let's go. Come on, please. All right. Whew. All right, friends. That was. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem, today's contest, you know, anything in between. Yeah, stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye-bye.